So in 14.1 we did objects made from cubes. Now we're going to make objects from rectangular prisms, boxes. So the volume of a cube, right, means all three dimensions, the length, width, and height, are the same. So 7 times 7 is 49, and 49 times 7, 7 times 9 is 63, and 7 times 4 is 28, and it's 343 cubic inches. So we're going to draw a rectangular prism that is not a cube, right? A cube is a special rectangular prism, just like a square is a special rectangle. So how did I say to draw 3D objects? Draw a rectangle instead of a square for the front. Then the lines going back are the key. They have to be parallel to each other, the same length. Connect them. If you mess up, which I just did, in more than one way, there you go. And if you want to put the hidden edges, you can dash them like that. And this is the length, width, height. So we did rectangular prisms surface area. That was how much gift wrap, all right, was around the outside, the surface. Now we're going to do what's the size of the maximum size of the present inside. What is the biggest thing that would fit in this box if it filled every inch of this box? Every cubic inch of this box. So you just multiply length, width, and height again in any order, commutative property, right? 10 times 6 times 8. Well, I'm going to do 6 times 8 is 48, because then I can multiply it by 10, just add a 0, and it's 48 cubic inches. It's that easy. So 48 cubic inches of paper or dirt or anything else could fit in there. Now typically we use volume for solids. We don't tend to use it for liquids like water, because those aren't measured. They can be, but they're usually measured in cubic inches. They're measured in things like gallons and quarts, right? So again, same thing here. So this is 10 times 6 times 1, which is just 60 cubic inches. So then what's this? Well, there are 4 of them, so it's 60 times 4. It's the same thing as the one on the left, so it's 240 cubic inches. Or, right, it's 4 of the ones on the left, or you could just do 4 times 10 times 6, right? You will get exactly the same thing, 240 cubic inches. So fill the volume paper that will fill half of this, right? So it's 1/2 of the length, width, and height. 1/2 times 10 times, let's put the height last, times 6, right? You can do half of any of these. I'll do it of the 10, 5. 5 times 4 is 20. 20 times 6 is 120 cubic inches. So say that would fill it up. 120 would fill it up halfway, right? All right, triangular prisms, just remember that triangles were half the size of rectangles, right? When we did triangles, right, if you do that area, that, I have to make it a straighter line, but, right, that area is exactly half if I've drawn it correctly. Even if I go like this, by the way, as long as I connect, it goes to the corners there, exactly half of the area. Now, same thing here. This triangular prism is half the size of the rectangle. So now there is a formula for the triangular prism volume, but do you really need it? It's half the size of the rectangular prism, right? The rectangular prism would be 12 times 20 times 10. So any triangular prism that has to go right to the edges of, in the corners of the box, but it's 1/2 of that. So 2 goes into 12, 6. 6 times 20 is 120. 120 times 10 is 1,200 cubic centimeters for the I'm going to say the triangular prism. Find the volume of the entire solid object. So hopefully you see a rectangular prism there, and you see a cube. The rectangular prism, now, what is this dimension? We need this dimension here. Well, it's got to be the same one as that, so it's 7 and then it's 7 this way, and then it's 16 tall. And we're going to add that to the cube, which is obviously 7 times 7 times 7. Hopefully you can, right? That's a cube because all edges are the same. They're all 7s. So 7 times 7 is 49, and 49 times 7, 7 times 9 is 63, 7 times 4 is 28, plus 6 is 343 cubic centimeters. This one is 49 again, but now we're times 16. And 6 times 9 is 54. 6 times 4 is 24, plus 5 is 29. We're going to step over and multiply by 1. And we get 18. I'm getting 784 cubic centimeters. I've got to add up those two. And I'm getting 1,127 cubic centimeters for the volume of the entire object. Find the volume of the larger rectangle not occupied by the cube. In other words, what's the rest of the volume? So this is a subtraction, right? It's very much like where we took the corner away from the rectangle, right? We took this corner away. You're going to subtract. So you find the volume of the rectangular prism. I should abbreviate that maybe that way. And then we're going to take away, it says that's a cube, okay? So the cube, it says right there, is 3 by 3 by 3. You know that because it says cube. So 3 times 3 is 9, times 3 is 27 cubic inches we're going to subtract. So now this 6 is this whole height. And so the rectangular prism is 10 times 4 times 6. 4 times 6 is 24. The whole thing is 240 cubic inches. So 240 cubic inches, take away the 27 cubic inches, and I'm getting 213 cubic inches. So how many bags of sand that are 80 cubic inches will fit in the box below? This is a division problem. We did ones like this before with area. So 10, right? So 10, we have to do 30 times 8, 3 times 8, 24, 30 times 8, 240, times another 10, 2,400 cubic inches. And we want to know how many times 80 cubic inches fits in there. So let's see, we can cross out the zeros, and then we have to do 8 into 240. Well, we could almost do that in our head, or maybe not almost. We could do that in our head. And so there, remember these units cross out, and there's 30 bags of sand would fit in there, right? How many 80 cubic inch, right? Because 80 times 30 will make the 2,400 cubic inches of volume. So we just multiply the 3 dimensions. 8 times 10 is 80. And then we're going to do 80 times 9.6. 6 times 0. 6 times 8 is 48. Step over, that's a 9. 9 times 0 is 0. 9 times 8 is 72. And we got one number to the decimal, to the right of a decimal. So 768 cubic inches of presents will fit inside, right? Very different than the gift wrap. The gift wrap, right? Just to remind you, right? We multiplied all the dimensions, and then we added up the 6 sides, right? Right, then you would do 9.6 times 10 and get 96, and you would do that twice. And then what was the last one? What's left? 8 times 9.6, whatever that is. And you would add them all up and get the surface area, how much gift wrap. We're finding today the volume. What's the maximum size present that would fit inside? 768 cubic inches. Right, so one of these, right, is 7 by 5 by 16 feet. So it's 7 times 5 times 16, 35 times how many? Times 4. And you can multiply those in any order you want. 7 times 5 is 35. 16 times 4 we've done recently. So let's just do that. 64. So we just have to do 35 times 64. 4 times 5 is 20. 4 times 3 is 12. So it's 14. Step over. 6 times 5 is 30. 3 times 6 is 18. Plus 3 is 21. And I'm getting no decimals. 2,240 cubic feet. Right now, the way I did it, I didn't really calculate what one of them is. So let me just do one of them. So one of them is 35 right, times 16. Let's see that. 6 times 5 is 30. 3 times 6 is 18, plus 3 is 21. Step over. 1 times 35, 6. So one of them is 560 cubic feet, and hopefully 560 times 4 will get us the same answer, 2,240 cubic feet. So again, so this is one where we have to add the line. Very similar. So now it depends on where you want to add it. Let's see. So we have I'm going to add a line right there. So I'm going to basically make a box, right? So now I've made a box that looks like this. Oh, I've made it longer than that though. Now I'm going to start again. There we go. And right, these lines going back. So there's a box on the bottom that looks like that. That's 20 by 20 by 12. All right, so let's do the volume of that. 20 times 20. 2 times 20 is 40, so that's 400, and then we have to do 400 times 12. 2 times 0, 2 times 0, 2 times 4 is 8. Step over, 1 times 400. So the bottom section is 4,800 cubic inches. Now on top of that, resting on top of it, is this other rectangular prism, and that rectangular prism, let's see if we can get the dimension. That looks more like this, right? And that one's sitting on top. Now, this is not 24. 24 is this whole length here. Okay, but it definitely says right there that it's 10 this way. Now there's some interesting things here, right? Because maybe I should have chosen a different way, but we can figure it out. So this is 24 and this is 12, right? So this has to be 24 minus 12. This has to be 12 inches right there. So that's 12. And then we need this dimension here. Well, it's also 20, right? Because it's the same length. So we have this one. Well, let's do 12 times 20 is 240, and 240 times 10, that one's 2,400 cubic inches. Oh, it's half as big, right? Because it's the same distance back, 20. It's the same width, 10, but it's only 10 inches wide rather than 20 inches wide, right? 10 inches wide instead of 20. But both sections are 12 inches high. So we have to add them both up, right? We had the larger one, which was 4,800. We have the smaller one, that's 2,400. And the whole thing is 7,200 cubic inches of volume. All right, so triangular prisms are half the size of the rectangular prism. So the rectangular prism, right, would be 6 times 20 times 8. For the triangular prism, all you got to do is add a half. It's half as big, as long as you're going to the corners. So it's a half times 6 times 20 times 8. So half of 6 is 3. So 3 times 20 is 60, and 60 times 8, that's 480 cubic centimeters, right? This would be 120 times 8. And is that 900? And it should be twice as big, right? The rectangular prism that you see in the dotted lines is 960 cubic centimeters. But the triangular prism, I got a little sloppy here, triangular prism is going to be half as big. All right, so how many of these 9 cubic inch bags fit in there? That should have been a little 3 there. So this is 3 times 3 is 9 times 10, 90 cubic inches. Oh, this is easy. How many 9 cubic inch bags will fit in there? Exactly 10 bags. Good luck with the homework.